For this Chapter 3, Example 5 problem, we have an 80-liter vessel, and it has 4 kilograms of refrigerant 134A, and at a particular pressure. And we want to find various properties of this refrigerant 134A at a single state. So let's go with our engineering model. So we got our known is basically we have a vessel holds 4 kilograms of refrigerant 134A at a pressure of 160 kilopascals. Okay. Sometimes you don't put in many of the details, but we only have this one small sentence that we're looking at. We're looking at find. And here we want to find 4 different things, right? A, we want to find the temperature. B, we're looking for the quality. C, we're looking at the enthalpy. And D, we're looking at volume. Those are the qualities we want to find. So we have a vessel, and we think about, I'm going to draw this. We're given pressure. So here's our pressure on our Y, and we're looking at specific volume over here on our X. And when we draw our curve for our liquid vapor, right, we're at a particular temperature, and we're told right off the bat we want to find the quality. So we know we're somewhere in here. Okay, so that gives us an idea, and this is for refrigerant 134A. Okay, so I always like to draw a scheme. So we have some type of vessel. I'm just going to draw a tank. And we got refrigerant 134A in here. It has a mass of 4 kilograms and a pressure of 160 kilopascals. So that's some information that's provided. So if we're looking for A, we have a temperature. And again, when we're in that liquid vapor region, pressure and temperature are dependent on one another. So once we find the pressure on our liquid vapor table, we can find the temperature. So here we're at 160 kilopascals. This is in bar, so we're going to go ahead and convert this. So we have 100 kilopascals is a bar, and so our pressure is 1.6 bar. Okay, so we look at 1.6 bar, and here's our temperature. So our temperature for part A is going to be negative 15.62 degrees Celsius. So that's our first part. For B, we need to find the quality. And think of things for our quality here. This is equal to the mass of our vapor over the mass total. But we don't have the mass of the vapor, so we can also think of it, another equation that we can use to find the quality is if I know the specific volume and I know the saturated liquid and the saturated, right? The saturated liquid and the saturated vapor, I can find the volume that I need right there. And so the volume, specific volume minus the specific volume of our saturated liquid, and our saturated vapor minus the saturated liquid, and that would be our quality. So we need these values here. For H, well, we have the table. I'm just looking at equations right now. The table here has some specific enthalpies, and we have a relationship here that if I know, again, we're in the middle, the condensed liquid or the saturated liquid is plus the quality, and the saturated vapor minus the saturated liquid. We can also, the tables also have this other value on here already, HFG, which is already that difference. Okay? And to think about the last one, our volume, well, if we know the, and this is the volume of the vapor phase, so we want the volume of our vapor phase, we need to know the mass of the vapor and the specific volume of our vapor. Okay? So those are various things that we need, equations that we need. So looking at this, because I'll need to take the table out of the way, let's look up some values. So the values that we need are our specific volume, and I'm going to write all three of those down. So let's go ahead and write our values down from the table. So we have BF. Don't forget this here. Our saturated vapor, our enthalpy of our liquid. I'll put all three of these down. All right. So we already found A. We looked at the temperature. Looking at B, where we want to find the quality. And here, since I have the volume, right, we're going to use this equation where we're going to use this equation here where we have, we need the specific volume and we know the volume of the container here. The volume of the container, which I forgot to write down, is 80 liters. So let's find the specific volume. And so the specific volume is going to be our volume divided by our mass. And so we have 80 liters divided by 4 kilograms. And we have to do some converting here. So a liter is 10 to the third milliliters. A milliliter is a centimeter cubed. And 100 centimeters cubed is 10 to the 6th cubic centimeters for every 1 meter cubed. Okay, so 80 divided by 4 is 20, and divided by 1,000, so this is equal to 0.020. So this is equal to 0.020 meters cubed over kilograms. So that's our specific volume. So to find the quality here, we're going to take our specific volume, saturated liquid, saturated vapor minus saturated liquid. So we just put our numbers in. Okay, so if we, right, the units will cancel because this is meters over kilograms, meters cubed over kilograms. And so we get our quality to be 0.1576. Okay. So that is our quality. So we can easily find it. Okay. C, we're trying to find our enthalpy. And so we're going to use our equation, specific enthalpy, and we're going to, I'm just going to, either one will work, but since they already took the difference for us, we're going to go ahead and put that in. And so our values here are, and when we multiply that together and do that addition, we find it's, our enthalpy is 62.59 kilojoules per kilogram. And you know, to double check to make sure, right, your answer must be in between the saturated liquid and the saturated vapor. So, and it falls in between there, so I'm pretty confident about that. And then to find our enthalpy, right? Enthalpy is going to be the mass times our specific enthalpy to get just in kilojoules. So if we put our values in here, and so our value 4 times that comes out to be 250.4 kilojoules. So that's our answer for C. And for D, we want to find our volume that's just occupied by the vapor. And so we have this value right here. We need to find our mass of just the vapor itself. And so we can do that by using this up here, our quality, right, is just the mass of our vapor divided by the total mass. And so if I want the mass of just the vapor, take the total mass times the quality, since we found it. Mass of our vapor comes out to be 0.6304. And so when we find the volume of our vapor, and that comes out to be 0.07748. And that is our value for our volume of occupied just by the vapor.